Welcome back, students. It is the second part of the video, circulatory system of human beings. In this video, in the first video, we have discussed about the human blood, its composition, its function, and group. Now, in this second part of this video, we will discuss about the human heart, its structure and function, and double circulatory system, and these are listed here. So, first. We proceed, we go back to this topic, blood circulation. In blood circulation in human beings, the blood circulation is constituted with three components: blood, heart, and blood vessel. What is blood we have described in detail, and what is heart and what are blood vessels. These are the two components to be studied here in this video. So before I explain the structure of heart, let me tell you what are blood vessels. Now just for a reference, I am giving the definition of the blood vessels. We will discuss in detail all the blood vessels in the later part of the video. The blood vessels are mainly of three types: artery, vein, and capillary. Arteries, veins, and capillaries. Which blood vessel is called artery? A blood vessel which carries blood from heart to tissue. Which carries blood from heart to tissue. Because it takes away blood from heart. This blood vessel is called artery. This blood vessel is called artery. And the blood vessel which carries blood from all the cells of the tissue back to the heart is called vein. And the blood vessel which are present in between vein and artery for the exchange of the substances are called blood capillaries. Will just it is just a reference, because while we will draw the structure of heart, we need these terms many times to tell about. So this is why you should know of this. So as so far heart is concerned, human heart, it is the central part of the blood circulatory system. And the blood is a hollowed pumping organ. It is made up of the muscles called cardiac muscle, and this heart is present in the thoracic cavity on the left hand side from the second rib to sixth rib. Means what is cavity? Cavity is a hollowed part. Means this beneath underneath these ribs there is a hollow part, hollow space. This space underneath these ribs is called the thoracic cavity, and the region in which the in which the digestive part are present is called abdominal cavity. So human heart is a hollowed muscular pumping organ which is present in the left hand side of the thoracic cavity from the second rib to, so far its location is concerned, from the second rib to sixth rib. And the size of human heart is of the size of his own fist or her own fist. Means if it is male or female, irrespective of the gender, and the size of the person is equal to the size of its his or her fist. Say for my example, size of my heart is equal to the size of my fist, and this heart is covered with a protective layer, and this protective layer is called pericardium. It is called pericardium. This pericardium is a protective layer. It protects heart from the injuries, mechanical injuries. Somehow, not major injuries, but some normal injuries because of the body movements, unusual body movements. It still protects heart from the jobs. And so now we will go. This is all about its structure. We will discuss now its structure, because in many board exams, it is most of the times noticed that the question is asked in the board exam: draw a well-labeled diagram of human heart. Well-labeled means draw a diagram of human heart and note down its part. Write the names of its different parts. It is a question I notice most of the times in the board exams. So let I explain you, and you follow me. How do I draw it and how I nominate it? So before we proceed, let I explain you. Human heart is somewhat of the structure of triangle. The broader side of the triangle is upward and the narrow part of this triangle is downward. It is this way. See, it is a triangle. Similarly, let learn how I draw this human heart. It is very simple. Draw a structure like this triangle. This way, it is broadened from upside and becomes narrow downward. Not exact, very. Keep it this way. Not exactly pointed this way. Make this outline this way. It is somewhat like this triangle, the broader part upside. Then draw a very another line very close to this, but do not touch this line with the outer layer. And about this, if we take, it is up to this 1/4 part. Up in this 1/4 part, make a chamber this way. I am drawing here, and then carry your drawing downward this way. And the point to notice, I explain you. Similar, you will do here. Make another chamber, drawing this line very close to the outer boundary, and to 1/4 part upper part. Keep it confined to 1/4 part of the total size you draw, and then run it downward and make another chamber. The point to notice is that the space here between these two layers is lesser, and the space between these two layers is more. Draw the same, because the thickness of these parts, the thickness of the upper chamber is lesser than the thickness of the lower chamber. So one heart is composed of consisting four chambers, two upper chambers and the two lower chambers. But I explain you in different way. The human heart is having two parts, left part and the right part. When we draw a human diagram of any organ of any human body, when we draw a diagram of human body, keep in your mind that when you draw, the side of that organ is exactly the opposite of your side. Say it is my right hand side, then in the diagram, this part is the left part is the left hand. The part on the right hand side of the drawer, the person who draws, is opposite to the part. So this is the right hand, and so it is the left side of the heart, and it is the left hand, so it is the right side of the heart, right side. So these are. Now draw a vessel this way, and draw another vessel this way, and another vessel at this portion this way, and another vessel here this way. It is your heart, very simple diagram to draw, and now I will name them. This side of the heart is left side, and this side is the right side. So human heart is divided into two halves, right half and the left half. And between these two parts there is present a septum. It divides, it keeps the two parts of the human heart separate. It is known as a septum. In this septum there is present another organelle. It is called SA node. From this SA node, very fine branches, they run all over the human, in all over the muscles of human heart, means in the cardiac muscle. It is known as draw this way entirely, it is known as a node. It is called as a node, and the branches, very fine branches which run through the muscular wall of the heart are known as Purkinje fiber. Purkinje fiber. Purkinje fibers. So it is the structure of human heart. Now we will name them. This broader part, this cell is aortic. It is called superior aorta, aortic aorta, and these blood vessels are called superior, and draw it this way, downside. Superior and inferior vena cava. Inferior vena cava. It is the upper part. It is called auricular, because this side is a left side. It is a left auriculum. You may write it here, left auriculum. It is a right auriculum. It is left ventricle, and it is a right ventricle, It is a pulmonary artery, and it is a pulmonary vein, It is human heart. It is a human heart. This is how you need to draw. Just learn how to draw. Later on, you will come to know very easily why these are named so and so. This is about the structure. Now I explain its functioning. Human heart is constituted of the two parts, left part and right part. Every part, left and right, has two chambers. The left part has two chambers. The upper chamber is called auriculum because it is present on the left hand side. This is why it is named as a left auriculum. It is named as a left auriculum, and below this chamber there is another chamber. This chamber is called left ventricle. Between these two chambers there is present an opening. It is known as AV aperture. This AV aperture is provided with a wall. These are two walls. These two walls are called AV walls, oroventricular walls. These oroventricular walls, they ensure the stoppage. They do not allow the backflow of the blood. How, I will tell you in the later part of the video. So it is there are two chambers, upper auriculum and lower ventricle in the in the left part. Similar is the case. There are two chambers which are present on the left hand side, right hand side. The upper is called right auricular, and below this there is another chamber. It is called ventricle, right ventricle, and there is an opening between these two. It is known as AV aperture. And this AV aperture, this side is also also facilitated with these walls. These walls are called AV walls. AV walls. So we can in itself say that the human heart is of four chambers: two upper auricles, left and right auricles, and two lower ventricles, left ventricle and right ventricles. So this is all about it. What about its functioning? Say, in the human heart, the main function of this heart is to pump the blood. It pumps the blood with such a phase that the blood can reach to every cell of the body, and in this course to supply the blood to entire body, the heart beats strongly. Beats strongly. There is a rhythmic contraction and relaxation. This way, there is a rhythmic contraction and relaxation. This contraction and relaxation in the human heart is operated by this SA node. This SA node, The rhythmic contraction and relaxation. The rhythmic contraction and relaxation of the human heart is operated or is regulated by this SA node. This SA node is called pacemaker of the heart. It is like it supplies electrical impulses, and these electrical signals impulses they spread through these Purkinje fiber in the entire muscular wall, and as a result of this heart beats. Say, take notice of this video. In this video, this spark is produced here by this SA node, and when this node it generates an impulse, this impulse is spread through this Purkinje fiber all over this heart muscle, wall, and as a result of this spread of this muscle, there is contraction and relaxation. See here. This is how the heart is rhythmically contracting and relaxing. The rhythmic contraction and relaxation of the human heart is called heartbeat. It's called heartbeat. A human heart normally beats 72 times a minute. Means in a minute a heart it beats 72 times. Means a beat is a set of one contraction and relaxation. Means when the chambers of the heart they once go under contraction and then they relax. This complete set of contraction and relaxation is called heartbeat, and there are 72 heartbeats a minute in a normal healthy human being. So this is so let me explain the working. When the main function of this heart is to pump the blood to entire body, and this blood is supplied with oxygen, and it also collects blood from body. It supplies oxygen in the form of the oxyhemoglobin, because the hemoglobin present in blood, it has the capacity to bind with oxygen to form oxyhemoglobin. This blood which is rich in oxygen is called oxygenated blood, and the blood which lack oxygen but has more concentration of carbon dioxide is called carboxylated blood, means carbonated blood. It is lesser in amount. So see here, the blood from entire cell, from all the cells of the body, of the tissue, is taken by the veins. I said you, the vein are the blood vessels which collect the blood from entire body, from entire tissue. These veins they carry blood from the cells, and then by the help of superior and inferior vena cava, it is a superior vena cava and inferior vena cava. With this superior and inferior vena cava, the carbonated blood, the blood rich in carbon dioxide, it reaches into right auriculum. So it is, I am explaining now the working of the heart. The carbon dioxide containing blood, it is collected from all the cells of the tissue, and then these veins they meet to form a bigger vein, and the bigger vein they still meet together to form still bigger, and ultimately the two veins, superior vena cava and inferior vena cava, they open in the right auriculum by two apertures. By two aperture, one aperture of the superior vena cava and another aperture of inferior vena cava. These aperture they fill carbon dioxide, the blood containing carbon dioxide. Now the blood it reaches into the right auriculum. When there is contraction, this contraction will create a pressure on this blood, and the blood will be passed into ventricle. In the ventricle, corresponding ventricle means there is always a particular flow. The blood from the right auriculum reach into the right ventricle. Similarly, the blood from left auriculum reach into the left ventricle only. So carbon dioxide containing blood, it when the auriculum, right auriculum contracts, it reaches into the ventricle. This carbon dioxide containing blood, when reach into right ventricle, by contraction, there develops a pressure. With this pressure, this carbon dioxide containing blood, it by this aperture is sent into the pulmonary artery. Artery is that vessel which take away the blood, because the right ventricle sends this blood to the pulmonary, means to the human lungs. Human lungs. In the human lungs, the blood. These are the lungs here. In the lungs, when the blood reach there, when the blood reach in lungs, the carbon dioxide present in the tissue, it reach. The carbon dioxide present in the blood, it diffuses into the lungs, and the oxygen which is filled in the lungs is carried back in the blood. So the blood, the carbon dioxide is released in the lungs, and the oxygen is carried in the blood. So this blood which is rich in oxygen, is taken up by the pulmonary vein. It is vein. I said the vein is that vessel which collects the blood, which brings the blood to heart. Because this vein, it brings blood from lungs. It brings from lung, and there are two veins, pulmonary veins, one from the right lung and another from the left lung. These two pulmonary veins, they two meet together, and then they take the oxygen containing blood into the left auricle, and this blood reaches here in the left auricle, and this blood is rich in oxygen. When there is a contraction of the left auriculum, the blood is passed down in the ventricle. Blood is passed into the ventricle. In this ventricle, when the ventricle it contracts, it sends this oxygen containing blood through this aortic aorta, the biggest artery of the human body. And this artery, because the contraction, it develops a very high pressure. It develops a very high pressure in the blood. Due to the contraction of the muscle, the pressure is exerted on the blood, and the blood it is passed into the artery in aortic aorta with a high pressure, and the blood, this pressure is known as the blood pressure. This pressure which is exerted on the blood due to the contraction of the ventricle is called blood pressure. This blood pressure is maximum in aortic aorta. Then this aortic aorta further divides into many branches, and still find branches, and ultimately it ensures the supply of the oxygen containing blood to every cell of the body. Now this is then the blood with the branching, the blood pressure goes on decreasing. Highest blood pressure is noticed into the aortic aorta. So there are now two things to note down here. Let I explain you. This is all about the functioning. The blood is carried from entire body by the veins. These veins together meet to form bigger veins. These bigger veins, they still form a still bigger vein, and then ultimately by two veins, superior and inferior vena cava, the carbon dioxide containing blood it reaches into the right auriculum. Then by contraction of this right auriculum, the blood reaches into the right ventricle. When this right ventricle it contracts, the blood is supplied through the pulmonary artery to the lungs, and in the lungs carbon dioxide is debodied and oxygen is bodied in the blood, and this oxygen rich blood is through the pulmonary vein reaches into the left auriculum, and this upon contraction sends its blood to left ventricle, and this left ventricle upon its contraction sends this oxygen containing blood through aortic aorta into the entire body. Thus you must notice here in this course, the blood passes twice in the heart. It is known as double circulation. What is double circulation? Double circulation, the human heart, or in case of human heart, in the higher organism with the which have four chambers of the heart in them, like the mammals and the birds, the blood passes twice through the heart in its course. First carbonated blood, it passes through the right part of the heart, and then the oxygenated blood it passes again through the left half of the heart. Thus the heart passes twice through the heart. This is known as double circulation. This double circulation is of utmost requirement in the organisms of a higher cellular organization, like the mammals, which have well developed heart and have the 4 chamber, because being complex organization, their energy need is very high, and this energy is produced by the oxidation of glucose in the respiration process in the cells, and this need more energy, more oxygen supply. And to ensure the more oxygen supply, the nature has blessed these organisms which have such kind of the cellular organization, which have 4 chamber. The oxygenated blood and the carboxylated blood, they does not meet each other. The organisms which have such a system cannot tolerate the mixing of the blood containing oxygen and carbon dioxide. Carbonated blood and oxygenated blood cannot meet, because when these meet together, there will be a problem, and this oxygen supply will be somehow resisted, and this will cause problem to their survival. So it is for sure the blood does not meet, the carbon dioxide containing blood does not meet with the blood containing oxygen. It is there, the double circulation is provided in such organisms. But I explained in the course the other animals like the amphibians and the reptiles. They have heart which have 3 chambers, and in them the blood which is containing oxygen and which is containing carbon dioxide can meet to some extent. Such animals, these amphibians and reptiles, they can tolerate the mixing of carbon dioxide containing and oxygen containing blood to some extent. They can tolerate, but the higher organisms like the mammals and the birds, they cannot tolerate. And if we go for other organisms of lower organisms, like in case of the aquatic animals like fish, they have only 2 heart in them, 2 chambers in their heart, and there is no system of the separation of the oxygen containing blood and the carbon dioxide containing blood. They have very strong capacity to tolerate the mixing of the carbon dioxide containing blood and oxygen containing blood, because in such organisms survive in water bodies, water sources in water, they have gills for the exchange of oxygen and carbon dioxide. So through the same organ they exchange carbon dioxide, they release carbon dioxide in the water and take oxygen from water in the blood, and it is mixed properly. So it is how wide double circulation is required in higher organisms like mammals, because of the more need of oxygen. Now with this one another question, the one other topic is open circulatory system and closed circulatory. Open circulatory system and closed circulatory system. That I will explain here. I will explain here later on. The circulation of the blood only in the heart and the blood vessel. The circulation of blood is confined only between the heart and the blood vessel. This is said closed circulation. It is called a closed circulation. And if the blood it mix up together with the tissue, and it does not remain confined to the blood vessels only, it can go into the space between the cells and in the tissue, intracellular tissue space. It is called open circulatory system. The open circulatory system is most common in organisms of lower organization, and the closed circulatory system in case of the organism of higher cellular organization. It includes reptiles, birds, and also some amphibians and the mammalians at all. So now I explain you. This is all about human heart. So there is another topic, heartbeat. As I said you, the heart it goes under rhythmic contraction and relaxation. Due to this rhythmic contraction and relaxation, there develops a pressure in the blood, and this blood pressure is felt into the veins, into the blood vessels. This is known as heart impulse, or it is known as impulse. And this impulse is because of this blood pressure. And another topic, blood pressure. The pressure exerted on the walls of the blood vessels due to the pressure in the blood is called blood pressure. The pressure which the blood exert on the wall of the blood vessel is called blood pressure. It's called blood pressure. The blood pressure is of two types. In the two types, systolic and systolic. When heart contracts, I said you in the composition, the wall of the ventricle is thicker than the wall of auricle, because when auricle it contracts, it carries the blood to the ventricle, which lie immediately under this and does not need much effort to send the blood to the target. But the ventricle has to send the blood to the farthest distance. So to ensure the supply without any hindrance, it needs to create more pressure. This is why the muscles of the ventricles are much stronger than the muscles of the cardiac muscle of auricular part. And this is why the wall of the ventricle are so thick. When this heart contracts, the pressure in the blood vessel is maximum. This pressure is known as systolic pressure. This pressure is called systolic pressure. And it is in a normal human being is 120 mm of Hg. 120 mm of Hg. And when the heart relaxes, the pressure is said systolic pressure. The pressure exerted by the blood on the wall of the blood vessels at the time of the contraction of a heart is called systolic pressure, and it is 120 mm Hg in a normal human being, healthy human beings. And when the pressure exerted by the blood on the wall of the vessels, when the heart is in the relaxation mode, then the pressure is called systolic pressure. And in normal human beings it is 80 mm of Hg. 80 mm of Hg. The blood pressure can increase or decrease. If the blood pressure is below 120/80, it is written this way. Systolic is written first and then written systolic. 120/80. This is how the blood pressure is denoted. 120/80 is the normal blood pressure range, and if the blood pressure is lesser than this, it is called low blood pressure. Low blood pressure. And when the blood pressure is more than 120/80, it is called high blood pressure, or it is also known as hypertension. High blood pressure is called hypertension. And of the two, if we compare the two, low blood pressure and high blood pressure, the low blood pressure is more dangerous situation than the high blood. Although both are not the normal situation, they are the abnormal situation. They are challenging for the normal health. But if we compare the two, low blood pressure and high blood pressure, the low blood pressure is comparatively more dangerous, because when the blood pressure falls, then the supply of oxygen to the cells it also falls. And when the supply of the oxygen is somehow resisted or is somehow lower down, then the respiration and the production of energy is also affected. So it is more dangerous. Supply of the nutrients is false. So whenever there is low blood pressure, be very cautious immediately. And in case of hypertension, it can be tolerated to some extent. Normally at the time of heavy vigorous, the blood pressure increases, because the heartbeat, it also increases. It also increases to supply more oxygen. So high blood pressure to some extent can be tolerated. And now about heartbeat. What is heartbeat? Heart contracts and then relax in a rhythmic manner. It is known as heartbeat. And there in a human being, 72 times, it beats 72 times a minute. 72 times a minute. When it beats, it produces two sounds, lub and dub. Lub and dub. At the time of contraction, when this wall All these artery and aortic aorta and the vena cava and AV valve, tricuspid valve, bicuspid valve, they close and open. They close and open during the contraction. During the contraction, the sound produced is called lub, and when there is relaxation, then the another sound is produced. It is called dub. Lub, dub, dub, D-U-B, lub, dub. Now, there is a question: does the heart keep on beating regularly without taking any rest all through the life from birth to death? Then the answer is no. The heart works only half time of the lifespan. Means it's very interesting to know. See here, what is heart working? The contraction of the heart is called its working. Means the heart is working in the sense of the contraction. When the heart relax, then it is at rest. Means there I differentiate these two. When at the time of contraction, when the muscles are working, then the heart is working. When the muscles they relax, then the heart is not working. It is rest position and working position. So when we go, there are 72 times in 60 seconds, because a minute is constituted of 60 seconds. So there are 72 beats a minute, means in 60 seconds. So for a beat, the time is 0.8 seconds. The time is 0.8 seconds. In time of 0.8 seconds, when auricle contracts, it takes 0.1 second in its contraction. Because the auricle they send their blood to ventricle, so they do not need to have more efforts. So they contract for a 0.1 second time, and then the blood from auricles it reaches into the ventricles. Both upper auricle, right and left, they contract spontaneously at a time, and then the blood from right and left auricles it reaches into the left and right ventricle at the same time. The time taken by the contraction of the auricle is 0.1 second, means then rest of 0.7 second it rests. Now when it is auricle, when ventricle contracts, is contract for 3 seconds, 0.3 second. The 0.3 second time is taken by the contraction of the ventricle. Then the rest of the time it is in the rest form. So if we sum up two, then the total time of contraction of the auricle and ventricle is 0.4 second. Because one beat it takes 0.8 second time, and of the 0.8 second time, just see here, it takes only 0.4. It works only for 0.4 second, and rest of the time it is in the non-working situation. Means this is how the heart does not work regularly. It works equal to its half lifetime. Means it rests exactly the time it was. Means it works for 0.4 second and rest for 0.4 second. This is why it does not fatigue you and keep on beating from birth to death. And sometimes there are some cardiac problems. The beating is affected. There can be a problem in SA node. There can be problem with the walls. There can another problems in the flow by the clotting of the clotting in the blood vessels. So it can be there that the heartbeat is affected, and this is also called cardiac attack. It is also called cardiac. It is an abnormal situation of the heart in human beings. Now this is all about heart's working and heartbeat, blood pressure, and now we go for the next segment. Before we jump to the next topic, I explain you the heartbeat. The heartbeat in the human beings is heard by a device called stethoscope. It's called stethoscope. You must have seen a doctor wearing a device in his or her ears, hanging in the around the neck with a point with some diaphragm with a structure having some diaphragm. It is this way. This is your sphygmometer. See here in this picture. It is sphygmometer. Now there is another device. It is called this device it is known as BP apparatus or sphygmometer. It is known as a sphygmometer. This device is used to measure the blood pressure of the human heart. So this is all about human heart. Now the next is in detail we will discuss about the arteries. So see here. Now in detail the blood vessels. I said you the blood vessels are of three types. Blood vessels. The blood vessels are of three types. We will take example of artery and vein first in detail. Vein, and at the same time we will study the difference between them two, and then we will discuss. Then we will discuss about the capillaries. See, what is artery and what is vein? The blood vessel which carries the point of difference is the definition of the two. The blood vessel which carries blood from heart to tissue or cells. Tissue or cells is called artery, and the blood vessel which carries blood from the tissue to heart is called vein. It's called vein. The first difference is this. Another difference is this artery, it contains oxygen containing blood. It is the blood in the artery is rich in oxygen. And the second difference in case of vein, the blood in the vein is rich in carbon dioxide. Because by the pumping of this heart, the blood is to ensure the supply of the blood to the farthest distance in the body. The pressure in the blood should be more. So, in this sense, the pressure in the artery is more. The blood pressure is more in arteries, and the blood pressure in vein is low. Then another difference is that because the blood pressure in arteries is more, so to tolerate that pressure, the wall of the arteries are thick are more thick, or they are thick. They are thick. See here, I explain you. It is see here, the wall of the artery is thicker, but the wall of vein is narrow. It is thick it is less thick. Why? Because the pressure in artery is more than the pressure in the vein. So to tolerate that pressure, the wall of the artery are thick. This is another example. Now the fifth difference is that the artery, they do not have wall. They do not have wall in them, because the blood in the artery, it flows by the pressure exerted by the contraction of the heart. But what about vein? How the vein collect blood from the entire body? The vein, they do not have any such system, that pumping system which can pump blood from tissue into the heart. What they have the walls in them. They have wall in them. These are the walls. These walls, they are such in structure that they can open when the blood flows in the upward direction. Means when the blood flows upward, then these open and allow the blood to go up. But when the blood tries to go down, these walls, they close and do not let the blood go down, go back. There is only one sided flow of the blood, upward flow. Blood means from tissue to human heart. The blood, how does this happen? Why the blood it flows? Why the blood it flows from tissue into the heart? See here, by different motions, by the contraction, relaxation of rest of other muscle in the body. When there is a muscular contraction, say take example of the legs. when the muscle of the legs they contract, they exert pressure on the wall of the vein. Because of this pressure, the pressure develops here in the blood, and then there is a chance of the blood to go up or go down. Because there is present a wall system, this wall does not let the blood go down. What it will do, the pressure exerted on the wall will let the blood go up, and the blood goes to the next section of the vein. And now, when the pressure is exerted at this part, the blood again goes upward, does not go down because of these walls. So these are the walls which are responsible. These are the walls and the muscular pressure exerted by the muscular contraction which are responsible for the flow of the blood from the tissue into the heart. This is how. So sometimes it is when the soldiers they are in the standing position in when they are at alert position mode, they are set to constantly tiptoe on their foots, because regular standing without any motion of the muscles will let the blood collect in the veins, because until there is no contraction in the muscles in the rest of the body, the blood will collect in the veins and it will not reach into the human heart, in the heart, so the man can faint. So when I said, when you keep on standing, do not keep standing without motion, keep moving tiptoed, so that the muscle they can exert pressure on the veins and the blood can reach from the tissue into the mass. So this is the fifth difference, and the last difference is that there are many differences. The major are these here. The sixth difference is that the arteries they are deep situated. They are deep situated, which cannot see them. We cannot see them. They are underneath in the flesh. But the veins, these veins are superior. They are superior in position. They can be seen, because see here, these are the veins. You can see these veins are superficial, and while the arteries they are deep situated. So these are the six differences. I again in nutshell say what is the difference between artery and vein. The artery are those vessels which carry blood from heart to the tissue. Veins are the blood vessels which carry blood from tissue to heart. The artery they contain oxygenated blood. The veins they contain carbon dioxide containing blood. And the artery they have high blood pressure, but the vein they have the blood pressure low, and the wall of the artery they are thick. The wall of the vein are narrow and they are not thick. And another is that artery is not provided with the walls, but the veins are provided with the walls, which is mandatory. And then these are deep situated and the veins are superficial. These are all about the veins. Now, what are the capillaries? Capillaries are the fine branches of the artery, which are meant for the exchange of the substances in the tissue. See here. Let I explain. Let I draw here. It is a artery, and this artery I explain you here. See here, I have drawn capillaries here. The capillaries are the fine branches which are present between the artery and the veins. See here in this picture, it is shown this way, but I have drawn another simple diagram. This fine artery it divides into the fine branches. These are the fine branches 1, 2, 3, 4, and 5 and 6. So many branches. The thickness of these branches is of the thickness of equal to the diameter of a single cell. These are the thickness of the wall of the arteries is equal to the thickness of the diameter of one cell. So being so thin, they are very permeable. They permit the exchange of the substances on the basis of the difference of the concentration. So the oxygen present in the blood and the nutrients present in the blood, they from these arteries passes into the tissue. They passes into the tissue. So at the same time, the tissue which is having more concentration of carbon dioxide and waste, this carbon dioxide being more in concentration, it diffuses into the vein, into the arteries. So in the arteries, the point of exchange of the substances, the useful substances like the nutrients and the oxygen, and they are from the blood are sent are sent into the tissue, and due to being in more concentration, at the same time the carbon dioxide and waste which are in more concentration in the tissue, they diffuse in the capillaries. Then these capillaries, these are the fine branches, they again reunite, they join together and to form vein. So this is why this is the third type of the blood vessel. It is called capillary. Now the next is about the transportation of transportation in plant. Do the plant also need a transportation? Definitely, there is a need of the transportation of the different substance in the plants. See, in the plants, the process is called photosynthesis, formation of the glucose during daytime by the help of sunlight and carbon dioxide and water. This supply of the water from the soil, which is absorbed by the roots to the point of the synthesis of the in the leaves, because the water is present in the soil, so it is to be absorbed by the roots, and then the water and the minerals absorbed in the roots are to be transported into the leaves, because leaves are the place of the synthesis of the starch and other components other. So there is a need of the transportation. In the same way, the food which is synthesized in the leaves is required everywhere in the rest of the part of the plant where the photosynthesis is not taking place. So there is also need of the transportation of this food from the part of its formation to the part where it is not formed. So for this purpose, nature has bestowed these plants with a particular type of the tissue. This tissue is known as vascular tissue. Let us explain you. See here. See here, students. How the transportation in the plant is carried. The transportation in the plants is carried by the help of a particular tissue, specific tissue. This tissue is known as vascular tissue. The main task of this vascular tissue is to transport the useful substances, means water and minerals from root to shoot, and food from shoot to rest of the part. This vascular tissue is of two types. Again, first is xylem and another is phloem. The xylem, it is meant for the transportation of water and mineral. Water and mineral. It is having a upward flow of the water and minerals. Water and minerals. Xylem is composed of four types of cells: xylem packets, xylem vessels, xylem fiber, and xylem parenchyma. Similarly, phloem, this is the vascular tissue which is meant for the transportation of the food from the aerial parts, means from the leaves into the rest of the parts where the food is not synthesized. This phloem, it is also having four components, means four different types of cells: phloem cell tubes and companion cells, phloem fibers, and phloem parenchyma. We are meant here just to describe the cells which are responsible for the transportation. In both xylem and phloem, the phloem fiber and xylem fiber, we will discuss this later on in the tissue, plant tissue chapter in detail. But I explain in brief. Xylem and phloem fiber, these are meant for the stem of the plant. The stem of the stem is because of this, because different compounds they store in the xylem and phloem fiber, making them rigid. And similar xylem parenchyma and xylem phloem parenchyma, the function is there to maintain the different type of the injuries occurred because of any reason. Now, these two main components which are responsible for the transportation. In case of xylem, xylem packets and xylem vessels, these are the two types of the cells of the xylem which are responsible for the flow of water from root to shoot. There is an upward movement of the water and minerals. See, what is the major, how the water is transported? That water is transported only in one direction, upward direction in case of xylem, along with the minerals. In the plants, the aerial part is bigger in comparison of that part which is in the root. In this aerial part, a phenomenon takes place which is known as evaporation. Sorry. The excess of the water present in the leaves and excess in the leaves is released in the form of the water vapors through the stomata, and as a result of this there develops a suction pressure. What is suction pressure? Suction pressure. This suction pressure is like that pressure. Take a syringe, and in the syringe there is a tube, and in the tube is provided with a piston. When you push the piston upward, then it develops a pressure. This pressure, this suction pressure, because of this suction pressure, the medicine or any liquid is filled in the syringe. Similarly is the case here. The water when evaporated out, then there develops a suction pressure in the aerial part, and this suction it is responsible for the upward movement. Now these cycles, these are blind, means they are no opening, they are independent, they are hollow inside and are rigid and have small pores at their periphery. The water and minerals they enter through the pores, and then due to suction it keeps on rising, and then when it reaches here it comes out, and there is another side tube and trachea, and then it fills. There is not a complete single column throughout. These tracheids they are blind at the both ends. They have holes in them. Waters enter into the holes downward and then keep on rising up, and then when this trachea ends here, it enters into another trachea, and this way in the systematic manner water keep on increasing. Same function is performed by the xylem vessel, but the xylem vessel are not as much affected in case of flow of this water and minerals. These are also blind, but they are blunt at their ends, and comparatively the major transportation of the water is carried by the tracheids, and the same function is done by the xylem vessel. These are similar, but their walls is less thick, and they are also hollow, have aperture on them. The water and minerals they enter in the hole, and when they reach at the second end, then they enter this. Means these are contributing for the exchange of the water and mineral from one trachea to another trachea. Because at this particular there is one trachea, there is another trachea. Water rises due to suction to this one particular end. When this end is blind, then to let this water and minerals reach into the second trachea, these trachea vessels, xylem vessels, they perform their function. Means they also assist the flow of the water minerals upward. Now about the phloem. In the phloem, the main cells which are responsible for the distribution of the food are the side cells. The side cells they are having perforated ends. These are having ends. This particular one side has a perforated end, means, and the flow of the food is in the both direction, upward and downward direction, and this flow is by the help of the energy, and osmosis, the principle of osmosis is applied here. The starch which is formed during synthesis is dissolved in water, and because of this it enters into the cell, and there develops a pressure. Because you must have studied of endocytosis and exocytosis. Then in the cells, phloem cells, there develops a pressure, and this pressure it is responsible for the flow of this distribution of the food, and this is how in the plants the food is transported in the phloems and water in the xylem. This is all about with the transportation system in human beings and in plants. Meet you again with the next video, with the next life process excretion. Till then, keep on watching this YouTube channel, and don't forget to subscribe and share this before you leave the channel. Thank you.